Hey everyone, welcome to lecture 4 of CSE 4635. In this lecture, we will be taking a look at custom entities, XML namespaces, and XSLT. So let's get started. So we already know what entity means. An entity is basically used to define shortcuts to special characters. So if you remember from our last lecture, we had some built-in entities. For example, %LT semicolon replaces the angle bracket sign, that is the starting angle bracket sign, right? So when it comes to entities, instead of built-in entities, it is possible to define some user-defined entities as well. So for example, there can be three categories of user-defined entities: general or internal entity declaration, parameter entity declaration, and external entity declaration. We will be taking a closer look at each of them. For now, let's start with internal or general entity declaration. So consider something like this. You have an XML document with the element author, okay? Now imagine that this author element appears multiple times inside your XML document. And for the value inside the author element, you have to type down, suppose, Anas Jawad. Now, having to type Anas Jawad each time you come across the author element in your XML document can actually be quite cumbersome, right? So instead, what we can do is we can define an entity that replaces the text Anas Jawad, and whenever we have any part in the XML document that needs Anas Jawad to be written there, we simply refer to this entity. Okay, so let's see how that happens. So the syntax for defining a general or internal entity in our DTD file is very simple. You write the entity keyword, followed by the name you want to give to your entity, followed by the value that you want to assign to that entity. So in our case, if we take the previous example again, we have in our DTD file, we have the entity keyword followed by writer. So in this case, we are defining that our user-defined entity will have the name writer, and it will have the value Anas Jawad. Okay. So in our XML file, so we have this author element, and since we want this author element to have the value Anas Jawad, we simply replaced Anas Jawad with %writer semicolon sign. Okay. So when we do something like this, what will happen is our browser or any other parsing software that will read this XML file will come across this entity, and it will immediately know to replace this entity with the text Anas Jawad. Okay, so when we are creating this XML file, we don't have to write Anas Jawad every time we have an author element. We can simply write %writer semicolon, and we will be done. All right. So for both user-defined entities as well as built-in entities, you need to remember the syntax for writing down the entities. So remember, an entity will consist of three parts: the ampersand sign, followed by the name of the entity, followed by the semicolon sign. Okay. Now we move on to parameter entity declaration. So parameter entities are both defined and referenced within DTDs. They are generally used to keep DTDs organized and to reduce the typing required to write them. Essentially, what this means is parameter entities are used to lessen the number of things that we need to write inside our DTD files. So let's think of an example when that can actually be necessary. Consider this. We have declared an element called sample element 1, and it is categorized as a mixed category, which is, it can be PC data, or it can contain other nested elements like element 1, element 2, or it can be a combination of all of this. Similarly, we have defined another element called sample element 2, and this element has also been categorized as a mixed data, as a mixed category, like the previous one. Okay, so now imagine that we will have multiple elements like this, which will have the same mixed category as this. So you can already imagine that having to write this mixed category over and over again for each of the element can get quite troublesome, and our DTD file will look quite complicated, right? So what we can do is, instead of having to write this category down over and over again, we can simply create a custom entity or a custom parameter entity that refers to this list of parameters or this list of categories, And instead of writing this whole category over and over again, we can simply use that entity. Okay, so let's see how that can work. So imagine this is an example DTD file, and we have defined an entity using the entity keyword, and we have given it the name acceptable. So one thing that is the difference between your regular entities and your parameter entities is that instead of using the ampersand sign, parameter entities use the percentage sign. Okay, so getting back to our DTD file, so we have named our parameter entity as acceptable, and we know that it is a parameter entity because we have used the percentage sign here. Okay, and we have defined that this parameter entity refers to this list of parameters or this list of categories. So this specific entity refers to PC data or another nested element called data. Okay, so now let's see how this can be used inside our DTD file. So next we have defined an element called example list, and this example list entity has a nested element called example. So since example is a nested element, we need to define the example element inside our DTD file as well. So that's what we are doing here. We have defined an element called example, and next what we did is instead of writing down a separate category list, for example, we have used the entity that we just defined earlier. So writing down this line is basically the same as writing down this line, where we mention the category information itself instead of using the entity. So now the advantage of doing this is if we in the future have any other element that we need to add in our DTD file, and that element will have the same category or the same mixed category as this, then we don't have to write PC data or data over and over again. We can simply use the percentage acceptable semicolon parameter entity to do the same thing for us. Okay. Finally, since we have another element called data, we have defined our data element and we have categorized it as PC data. So now let's see how this DTD file reflects in our XML file. So in our XML file, we have the root element as example list, and inside the example list, we have two example elements. So in the first case, we have an example element, and it simply contains the data example1. So this example element conforms to the rules defined by the DTD because according to our DTD, this example element is referring to the acceptable entity, and this acceptable entity is defined as PC data or data. So since it is defined as PC data or data, so this example is correct. This example element is correct. Next, we have another example element, and in this case, we see that instead of directly having any data, it contains a nested element called data. Okay. So this this formation of the example element is also correct because in our DTD file, we have defined that the acceptable entity is referring to either PC data or another nested element called data. Okay. And so this example element formation is also correct. So this is how you can use parameter entities inside your DTD files. Okay. Now we move on to external entities. External entities point to external information that can be copied into your XML document at runtime. For example, you could include an inventory list or other file using an external entity. So the way you define external entities in your DTD files is very simple. You use the entity keyword followed by the name of the entity, followed by the system keyword, and finally, you mention the URI or URL that points to that external file. In this case, using the system keyword basically indicates that this entity is actually referencing some external file that is located on a server or somewhere else. So let's see the DTD. In this case, we have defined an entity called favquotes. Next, we have used the system keyword to basically indicate that this favquotes is referencing to some external file located on some server. And then we have defined a URL. So this URL points to an external XML file, as you can already see. And what we want to do is we want to use this entity to include that XML file inside an already existing XML file. So in this case, our XML file may look something like this. We have a section root element, and inside the section root element, we have another nested element called heading, and this heading contains some data, contains some information, as you can see. And finally, we are using our external entity here. So using this external favcodes entity here will basically copy all the content that is located inside this example.com/favestocks.xml file, and it will copy those content inside this section element here. Okay, so that's how external entities work. All right, now we move our discussion to XML namespaces. We know that the ability of XML to allow us to define our own elements is actually pretty cool. It provides us flexibility and scope. But it also creates the strong possibility that when combining XML elements from different sources, we will experience clashes between code in which the same element name serves very different purposes. So let's take a look at an example to understand what we mean. So suppose we are developing an e-medical system and we need to store information about patients and doctors. So we have a patients.xml file that is storing patient information and we have a doctors.xml file which is storing doctors information. So in both cases, you can see that both the patient and the doctor has an element called name, which denotes the name of the patient and the doctor respectively. However, if we were to combine these two fragments together, these two XML documents together, then there would be a conflict because there is an element with the same name in both the XML documents. But the problem is they might have the same name, but they are serving different purposes. One is used to denote the name of the patient, and one is used to denote the name of the doctor. An XML parser does not know how to differentiate between these two elements. Okay, there comes XML namespaces to the rescue. XML namespaces attempt to keep different semantic usages of the same XML elements separate and unambiguous. In our example, each person could define their own namespace and then prepend the name of their namespace to specific tags. So let's again take a look at our examples. Now you can see that in case of patients, we have appended or prepended the prefix ptn before our name element in case of patients, and in case of doctors, we have prepended the doc namespace before the name element. So what happens now is the name element in the patient has become different from the name element in the doctor XML document, right? So now there is no ambiguity between these two documents, and our XML parser will know how to handle these two separate elements. So essentially, XML namespaces allow us to create a unique namespace based on a URI or Uniform Resource Identifier, give that namespace a prefix, and apply that prefix to XML document elements. By the way, XML namespaces is actually a very core concept when it comes to XSLT, which we will be taking a look at later. Right, now let's take a look at how we can create XML namespaces. To use and declare a namespace, we must first tie the namespace to a URI. A URI can take two forms, URL and URN. URN stands for Uniform Resource Name, and it is used to uniquely identify a resource. It is not used to locate a resource. Remember that. Now, if you're confused about what a URN is, consider this. Each published book has a unique code called ISBN, which can be used to uniquely identify that book from all the other books, right? So we can say that ISBN is a kind of URN. So these two are some examples of URIs. The first one is basically a URL, and the second one is a URN. So in both of these cases, they are used to uniquely identify two resources. Now, the problem is we want to use namespaces across multiple elements inside our XML document, right? So having this big ass line of code or this big ass line of URI to uniquely identify each element can get quite troublesome because we need to write this whole line before each element, right? So instead what we do is we define a prefix to represent our namespace. So for example, in this case, we have defined a prefix called PTN, and it is referencing the namespace URN patient information namespace. Okay. Now we need to tell our parser that we are declaring or we are creating a namespace, right? To do that, we use the keyword XML So inside our XML document, we write something like this: XML PTN is equal to URN patient information namespace. So doing this will essentially let the parser know that we have created a prefix called PTN, and it is referencing the namespace URN patient information namespace. Okay. Now the question is, where do we put this XML namespace declaration? Well, that is pretty simple as well. In most cases, we declare them at the root element of our document. So if we take our previous patient XML file, it will look something like this. We have our patient root element. We have an attribute called ID. Following that, we have used the XML notation as an attribute, and this attribute is holding the value of the namespace that we are creating. So doing this lets our parser know that we have created a prefix called PTN, and this PTN is essentially referencing the namespace URN patient information namespace. So inside our patient root element, however many elements that we define, if we simply prepend the word PTN before them, they can be uniquely identified from each other. Essentially, what that means is, remember that we had a name element inside our patient XML file. So adding the keyword or adding the prefix PTN before that before that name element will essentially differentiate it from all the other name elements that may occur in some other XML documents. For example, in the doctor XML document that we had. Okay. In case you're still confused about how namespaces work, don't worry. This demonstration will help you understand everything much more clearly. So we have two files here, a sample XML file and a sample DTD file. We don't need to worry about the DTD file. Let's just look at the XML file for now. So in this XML file, we have the root element as course. Now you can see that inside our course element, we have a special attribute, XMLNS:CRS. Essentially, what we mean by this is that we are defining a namespace by using the XMLNS keyword. Okay, and in this case, we have defined a prefix called CRS, and this CRS is essentially referencing the namespace course information system. Now, since we have defined this namespace inside our root element, we can use this namespace across all the other elements in our XML file. So as you can see, we have used the CRS namespace for our web architecture element. And if we wanted, we could have used it for other elements as well. Now, what will happen is if we have some separate XML file, which has the same web architecture element, but performs some separate purpose, if we append it to some other namespace, then that element will become different from this element, from this web architecture element, okay? And so there will be no question of ambiguity anymore. Now, what you need to remember is that namespaces have scope. So for example, in this case, we have defined our namespace inside the root element, which allows us to use this namespace across all the elements that are nested inside this root element, right? Now, if we decided to define this this namespace somewhere else, for example, if we decided to define this namespace inside the lectures element, then we could have only used that CRS namespace inside our lectures element, okay? That is inside all the elements that are nested inside the lectures element. We could not have used it outside the lectures element, okay? So that's what scope means in this case. So that is how namespaces work. Hopefully you were able to understand them. Now we'll start our discussion on XSL and XSLT, which are basically styling technologies for XML documents. Now, before we start our discussion, it is important to note that the main purpose of XML documents is to store and carry information. How we decide to display that information is not that important, and so we will not take too deep of a look at XSL or XSLT. We will just have a brief overview of these technologies, okay? So with that out of the way, let's look at a few abbreviations. XSL stands for Extensible Stylesheet Language, which is used as a stylesheet language for XML documents. It describes how the XML document should be displayed. XSLT stands for XSL Transformations. It is both a stylesheet specification and a kind of programming language that allows us to transform an XML document into any other form of document. For example, we can use XSLT to convert an XML document into an XHTML document or an HTML document or even some other formats according to our choice. XSLT uses XPath and several other technologies to do its work. So what exactly is XPath, you say? XPath is a language for locating and processing nodes in an XML document. Because each XML document is by definition a hierarchical structure, it becomes possible to navigate this structure in a logical formal way, that is, by following a path. So we will see these things in practice by looking at various examples now. Consider that we have this very simple XML file, letter.xml, and it has some very few elements. It has a root element called letter, and under this root element we have three other nested elements called to, from, and message. Now, if we were to run this XML file from our browser, for example in Chrome, this is what we will get. Since this XML file is not associated with any styling information, so the Chrome browser simply displays or simply formats this XML document as a document tree. So this is what we will get when we load this XML file in our Chrome browser or any other browser. Now, let's see what happens if we did add a styling sheet or style sheet to this XML document. Okay, so everything is the same as before, but now we have added a style sheet reference. And the style sheet that we are referencing to is letterconversion.xsl, which we will be taking a look at later. But now let's see what happens after we have added the style sheet reference. All right, so as you can see, now instead of showing a document tree, the Chrome browser shows a kind of a table with a label at the top and some other information as well. So instead of showing the document tree, now we have a table structure where the column names are to and from, and we have some information from the XML documents in this file, in this reformatted data as well. So now let's take a look at the letterconversion.xsl file and see what exactly is happening there to make this conversion. Okay, so let's look at this document step by step. First, what you need to remember is an XSL file is a kind of an XML file, but with a separate extension. That is, it does not have the .xml extension, but it is an XML file for all measures. And so we have our XML version declaration here, similar to a typical XML document. The next element in our XSL file is the XSL stylesheet element. And this stylesheet element basically lets our parser know that this is a stylesheet file and it can be used to reformat some other XML document. Now inside this XSL stylesheet element, we have defined a namespace called XSL, and it is referencing to this specific URL. Now for all the XSL specific tags that we are going to be using in this XSL file, we need to be sure to insert this namespace. Otherwise, none of our templates or none of our XSL specific elements are going to work. So let's see what is happening after this. So now we have defined an XSL template element. For now, you don't need to worry what this template does. Let's look at the other elements first, and then we will come back to this template element. Okay. So now you see that we have an HTML tag inside our XSL file. So if you're already familiar with HTML, you know what HTML tag does. HTML tag basically refers to the fact that we are creating an HTML document, right? So in this case, we are slowly understanding that XSL essentially helps us reformat our XML documents by using various HTML tags. Okay, so we have our body HTML tag, we have our H2 header tag, and so on. In our header tag, we have defined the characters letter to mom, and then we have defined a table element to basically define that we will be creating a table. Okay, so we have defined the table border as 1, and after that we have created a table row element, and we have defined the background color for that table row as well. Inside this table row, we will have two table headers, to and from. So if you look back at the rendered format that Chrome showed us earlier, you can see that we do have to and from as our column headers or as our table headers, and they have the background color that has been defined using tr_bg color attribute. Okay, so after this first tr element has been declared, we have another table row. After this table row element has been declared, we have another table row element here, and this time we will be using some direct value from our XML document. And now comes the use of the XSL namespace that we declared earlier. So XSL value of element is an element that is available inside XSL files, which can be used to extract values from an XML document. So as you can see, this XSL value of element has an attribute called select, and this attribute is referencing to some specific elements inside our XML file, right? So when we write something like letter/to, what that means is that we are trying to select the value that is located under the to element, which is located under the letter element. So if you remember from our previous XML file, we did have a letter element, and under that letter element, we had a to element, which was nested, basically. So under this to nested element, we had the value mom, I think. Yeah, we had the value mom. And so that value will be extracted from that XML document, and it will be put under the table data element here. Okay. Similarly, we have another table data element, and this time we are selecting the value from the letter/from element. That is, we are extracting the value that is located under the from element, which was Tom, if you remember from our XML document. And so what we understand from this is that XSL value of element, this element, XSL value of element, is being used to extract values from some specific elements from our XML document. Okay, so by using this XSL tags, or by using this XSL value of elements, we are essentially taking values from our XML file and putting them inside this table that we are creating, right? After that, we have closed down all the tags that we had declared earlier. And now let's come back to the XSL template element that we mentioned earlier. So the purpose of this XSL template is to create a template according to what we have defined here. So just look at this this whole structure here. This is a kind of a template, right? So according to this template, we are going to have a header, we are going to have a table. That table is going to have a table border of 1. It's going to have some table headers like to and from, and so on. You get the idea. This is a kind of a template. So this XSL template element is essentially saying that whenever you find any element that matches the root element, then you apply this template. So since our XML file is referencing this XSL file, what will happen is, at first, this XSL template is going to match our XML file. So when it finds the root element of our XML file, it will basically apply this template on our XML file. Okay, and after this XSL file is going to be applied to our XML file, the information from that XML document can be extracted by using this value of elements here. Okay, so another thing is the value that we used for this match attribute as well as this select attribute are essentially XPath expressions. So this root element here essentially denotes that our the path that we are looking for is the root, and the letter /2 expression that we have used here is essentially telling us that the path that we're looking for is located under letter, again under 2. Okay, so XPath expression essentially works like traversing a file directory. Okay, the / is basically used to define subdirectories. So that is how this specific case is working. But the problem is, if we have multiple elements in our XML file, then, and if we wanted to use the XSL value of element to extract that value over and over again, then you can already guess what the problem will be, right? We will have to declare this XSL value of element over and over again for each of the entries that we have in our XML file. To skip that problem or to circumvent that problem, what we do is we use another element called XSL for each. Okay, so let's see in our next slide how XSL for each element can be used to traverse through multiple elements inside our XML file. Basically, how it is used to traverse through a loop of elements. Okay. Now let's take a look at this mails.xml file where we have mails as the root element, and we have 3 mail elements under this root element. So we have 1, 2, and 3 mail elements. Okay, and under each of these mail elements we have 2 from and message sub elements. Okay, so now you can already understand that if we simply wanted to use XSL value of element to get the value for each of the 2 from and message elements, then we would have had to write it 9 times, right? Because we have a total of 9 occurrences of these 3 elements. And so that is not a good design choice, is it? Instead, what we can do is we can use XSL for each element to loop through these elements here. And then we will only have to write XSL value of element 3 times. Okay, so let's see how that works by looking at the mails to table.xsl file. All right, so here we have our mails to table.xsl file, and just like the previous time, our XSL file starts with XSL template element. Okay, and just like the previous time, we are using match is equal to root to basically define that we will be matching this template whenever we come across the root element of our XML file. So we start off with our HTML tag followed by the body tag. Next, we have an h2 header tag, and we have defined the value as mail log. Next, we have defined a table element to basically state that we will be creating a table. And then we have created 3 table headers, 2, from, and message. So now starts our work of looping through the elements. Let's bring our XML file here so that we can match it to our XSL file as we go along the explanation. All right, so now we have started writing XSL for each element. So when we write, as you can see, this XSL for each element has an attribute called select, and inside the select attribute we have specified the value mails /mail. So what this line means is start scanning through this XML element, through this XML document, and whenever you reach this mail sub element under the mails root element, then what you will do is you will run a loop. So what will happen is for each instance of mails /mail element, each time you come across 2, from, and message elements, you will loop through them. Okay, so essentially we will be going across these 3 values once. Next we will be going through these 3 values, and then we will be going through this 3 values. All right, so once we have started writing our XSL for each element, inside that we will have table rows, right? So the table row will have 3 table datas because we have 3 elements, that is 2, from, and message. And inside those table datas, we will be using our XSL value of element to get the value from those elements. Okay, So we have XSL value of element for to, XSL value of element for from, and finally XSL value of element for message. Notice that we only wrote them once here, right? Even though we have 3 instances of this mail element, we have to write them only once in this case because we are looping through them, all right? So finally, we end our after finishing the table row element, we finish our XSL for each element as well, and we write down the closing tags of all the other elements as well. Now, if we run this in our Chrome browser, that is, if we try to display this XML file using our Chrome browser, let's see what we get. Okay, so as you can see now, we have a nice table here, a nicely created table, and we have all the 3 mail instances that we had in our XML file. So we have 3 instances for our to, from, and message headers. Okay, so that is how we can use XSL for each and XSL value of elements in conjunction to loop through multiple elements of the same type and get the value for each of those elements. Okay. There are various other complex functions that you can implement by using XSL, by using some other XSL elements as well. For example, we can apply if conditions as well. If you are interested, you can find those in the tutorial file that I will be attaching in your Google Classroom, but those are not too important for our course, okay? So that's it for today's lecture. Hopefully you were able to understand all the topics, and if you have any question, as usual, let me know in our live class. So I will see you in the next live class, all right? Take care and stay safe.